Hello, everyone. Our topic for today is about interpretation of assessment data with the use of statistics. There are different measures usually used in interpreting data. We can make use of the measure of central tendency. We could also make use of the measure of dispersion or the measure of position. We also have the measure of shape or the measure of relationship. In the measures of central tendency, these are used to determine the group performance of a group of scores. It refers to a single value that is used to describe the center of the data, and its typical value in a given distribution. There are three common measures of central tendency. One is the mean. We also have the median and the mode. I think you were able to encounter the mean, median, and mode already in the elementary as well as in high school statistics. But let me give you a little recall of it. The mean refers to the arithmetic average. It is used when the data are interval or in ratio of level of measurement. It is used when the frequency distribution is regular, symmetrical, or normal. However, mean is easily affected by extreme scores. It is very easy to compute. It usually is used to measure stability. It is used to compute other measures such as standard deviation, coefficient of variation, skewness, and the z-score. The median refers to the centermost when the scores in the distribution are arranged according to magnitude, or meaning from highest to lowest or lowest to highest. It is used when the middlemost score is desired, and it's used when the data are in ordinal level of measurement. It is used when the frequency distribution is irregular or skewed, and it's used when there are extreme scores. Because usually the median is not affected by the extreme scores because of its positional measure. It may not be an actual observation of the data set. The mode refers to the scores that occurs most frequently in the distribution. It is used when the data are in nominal level of measurement. It is used when quick answer is needed, and it is used when the score distribution is normal. It can be used for quantitative as well as qualitative data, and it may not be unique. It is not affected by extreme scores. May not exist at times. So we have different types of mode. Unimodal, the score distribution that consists of only one mode. So if you have a given data and you identified only one mode, that's unimodal. It's bimodal when the score distribution consists of two modes, like for example, in those scores, you have seen two appeared twice and three appeared twice and the other appeared once. So it's bimodal because you have two modes, the two and the three. Trimodal is the score of distribution that consists of three modes. So it's also considered as multimodal, a score distribution that consists of more than two modes. So you can have no mode, you can have one mode, or you can have two mode, three modes, and infinity. So we have here an example. The score is 10, 11, 11, 12, 14, 15, 16. If you look at the mean is the average. So you add up everything and divide into 1, 2, 3, 4, 5, 6, 7. You divide it into 7. So 10 plus 11 plus 11 plus 12 plus 14 plus 15 plus 16 divided by 7, that will be 12.7. So that's the mean. When you say median, you arrange the scores from highest to lowest or lowest to highest, like this one is arranged already. And then you look at the middle. So the middle is this one, 12. So this is the median. The mode is the number that appears most frequent. So here we can say that 11 appeared twice, so it's the mode because others appeared once only. The range will be discussed later. We have here measures of variation or dispersion. So it is a single value that is used to describe the spread of the scores in the distribution. So we have here range, standard deviation, and variance. Let's try to discuss them. The range is the difference between the highest score and the lowest score. It is used when the score distribution is normal, and it is used when the data are interval or in ratio level of measurement. It is used when a quick answer is needed and a rough estimation of variation or dispersion. It is easily affected by extreme scores. Usually, to compute the range is just the highest score minus the lowest score. Like for example, we have here the ages of the students. So the highest here is 18 and then the lowest is 11. So the range is 18 minus 11, so that is 7. So range is the highest score minus the lowest score. In terms of the variance is a measure of variability. It is calculated by taking the average of the square distributions from the mean. The variance tells you the degree of spread in your data set. The more spread the data, the larger the variance is in relation to the mean. So we have here the formula for the population variance, and here's the formula for the sample variance. So usually it's just the difference of the mean, and your score squared, and then there's a summation divided by the total number of observations. So example, let's talk first of standard deviation, and we'll have an example later. So here, standard deviation refers to the average distance that deviates from the mean value. It is used when the data are interval or ratio level of measurement. It is used when the frequency distribution is regular, symmetrical, or normal. The most important measure of variation or dispersion is standard deviation. The most commonly used measure of variation, particularly in research, is standard deviation and shows variation of individual scores about the mean. By the way, standard deviation is just the square root of the variance. So if you already have the variance, you just get the square root of it, and then that's the standard deviation already. So here, for example, let's find the variance and the standard deviation. Our score here is, we have 1, 4, 1, 3, 5, 3, 2, and 3. So the first thing that we need to do is let's get the mean first. So you add everything and divide by 7, you have 3. So our mean is 3. We know that our formula for the variance is the score minus the mean. And then we square it, right? And then we get the summation of it. We add it everything and then divide it with the n. So here, our x is 4, our score is 4 minus the mean, which is 3, so you get 1. Our score here is 1 minus 3, that's negative 2. We have a score of 3 minus 3, that is 0. 5 minus 3, that is 2. 3 minus 3, that is 0. 2 minus 3 is negative 1. 3 minus 3 is 0. So we have here now the mean, the score minus mean, so this one. And we need to square them because in the formula that we had a while ago, x minus mu then squared. So 1 squared is 1, negative 2 squared is 4, 0 squared is 0, 2 squared is 4, 0 squared is 0, negative 1 squared is positive 1, 0 squared is 0. And then we add everything, summation of it. So 1 plus 4 plus 0 plus 4 plus 0 plus 1 plus 0 divided by the number of data that we have, 1, 2, 3, 4, 5, 6, 7. So divide 7, it's 10 over 7, so that our variance is 1.43. To get the standard deviation, we just get the square root of 1.43, that is 1.20. So 1.43 is the variance, and then 1.20 is the standard deviation. If the value of the standard deviation is large, on the average, the scores of the distribution will be far from the mean. So kung dako ang imong standard deviation nga score, meaning layo siya sa imong center. Therefore, the scores are spread out around the mean value. And the distribution is heterogeneous, meaning dili siya dugol ang score sa mga nag-take sa example. No, lagyo yung score like 10, na ay nag-15, na ay nag-20, nga na, lagyo siya. Dili siya nga duol ang score nga 10, 10, 10, 11, 11, dili. Pag heterogeneous, ga-vary ang score. Dili siya dugol, dili siya pares-parehas. But if the value of the standard deviation is small, on the average, the scores in the distribution will be close to the mean. So duol siya sa mean. Hence, the scores are less dispersed, or the scores in the distribution are homogeneous. So when you say less dispersed or homogeneous, pares-parehas ang score, like 11, 11, 11, 11, 12, 12, 12. 11, 12, 13. Duol ra siya. Di siya lagyo atong pares ka ganiya. So when you say homogeneous, duol ra, pag hisimon ka heterogeneous, layo ang score sa mean kay gabari man siya. Like 10, ang isa 100, ang isa 15, ang isa 50 mo rin nga na ba? Heterogeneous na siya. Homogeneous, duol ra. Like you have 10, 11, 12, 13, 10, 11, 12, 15, mga na duol ra siya. And then we have also here the measure of position. It indicates where the score is in relation of the scores in the distribution. They make it possible to compare the performance of an individual on two or more different tests. So we have here an example, the percentile rank. The percentile rank is the percentage of scores in the frequency distribution which are lower. This means that the percentage of examinees in the norm group who scored below the score of interest. It is used to clarify the interpretation of scores on standardized tests. So let's have here an example. So by the way, we also have what we call as quartile, decile, and percentile. So when you say quartile, you divide it into 4 equal parts. You have the 25%, 50%, 75%, and the 100%. So those are the 25%, the next 25%, the next 25%, and the next 25%. So that's quartile. When you say decile, it's divided into 10 not decimal, 10. So 10%, 20%, 30%, 40%, 50%, 60%, 70%, 80%, 90%, and 100%. So what is the 80% of this distribution? Something like that. So, or what is decile 8? So that's 80%. When you say percentile, it divides the distribution into 100 equal parts, like 1, 2, 3. Like if you want to ask what is the percentile 50, you need to get the 50th of those scores, something like that. So let's have here an example to make it clear. So we have here the numbers 2, 4, 6, 6, 8, 10, 11, 18, and 20. To get the quartile, so you can make use of this to get the decile, this one, and the percentile, this one. So example, you want to get the quartile 1, so Q1, so your K is 1, so 1 over 4, and then the N is the total number of data that we have, 1, 2, 3, 4, 5, 6, 7, 8, 9, 9. So 9 plus 1, that's 10. Times our K, we want to get quartile 1, so this is 1, so 10. So 10 times 1, 10 divided by 4, you will have 2 point something, no? So your 2 point something is, let me see ha. So you have 10 divided by 4. So you will have 2. So that's 8, 2. So 2.5. So 2.5 is here. It's 6 already because you rounded up to 3, correct? So 2.5 is rounded up to 3. So that is on the third number. So this is 6. So this is quartile 1. If you want to get the decile 2, your K is 2 here, and this is 9 your N because you have 9 numbers here. So 10 times 2, 20 divided by 10, that's your decile 2 is the second number because this is 2. So that's why you get 4. And also your percentile, you can just get it like this. So this is an example. The second is we have the standard scores. We have here the z-score. The z-score is the number of standard deviations units a score is above or below the mean of a given distribution. So we have here a positive z-score means the number of standard deviation of a score is above the mean. And a negative z-score gives the number of distribution standard deviation below the mean. So if you have a positive z-score, it's above the mean. So it's on the right side. But if you have a negative z-score, that means it's below the mean, it's going to the left. So the formula of getting the z-score is the score, the x is the score, minus the mu, which is the mean, divided by the standard deviation. So for example here, if we have a score of 6, minus our mean is 5, and our standard deviation is 7, we just have it 6 minus 5 divided by 7 is 0.14. And it's positive, so it goes towards the right. It's above the mean because it's positive. No, 0.14 is positive. It's more than 0. So if you look into the standard deviation, 0 is your marker, and then above that, that's positive. Below 0 is negative, something like that. If you want to make your z-score beautiful, because the z-score usually is in decimal, so you can have the t-score. It tells the location of a score in a normal distribution having a mean of 50 and a standard deviation of 10. So you just multiply your z-score to 10 and then plus 50. That will be your z-score. So example, here we have 0.14 as our z. So if you convert that to t-score, you have 10 times 0.14. So that will be 1.4 plus 50. So that will be 51.4. So usually you have it like that. Next. Stanines are also known as standard 9, are single-digit scores ranging from 1 to 9, and the distribution of row scores is divided to 9. Like for example here, usually the formula is 1.96 times the z-score plus 5. So it has a mean of 5 and a standard deviation of 1.6. So example, you have a group of students in your class, and then you can just place them into different stanines, their scores. Like the highest scores, no, you get those from the highest, you get 4% of it, whose students belong to the stanine 9. So they're the top 4%. Or if you have the stanine 1, the lowest 4% of the scores of the student, something like that. So you can place your students in different stanines or standard nines. So you will know who are, because if you belong to the 5, you are average performing. But if you belong to 4, 5, and 6, then you are averagely performing. But if you belong to 3, 2, and 1, you are poorly performing. If you belong to 7, 8, and 9, then you are better performing than others. We have also here the measures of shape. We have skewness and kurtosis. So let's start with the skewness. Skewness describes the degree of departure of the scores from asymmetry. So if you can see here in the graph, we have here a negatively skewed, meaning the direction is going to the negative. And then you see the tail, it's going to the negative part of our linear, of our line, our number line. The normal distribution is it's beautifully shaped, no, normal. So if you see this in statistics, it's normal distribution. It's a normal curve. And if it's a positively skewed, you look at the tail here, it goes to the positive direction of our number line. So when you say positively skewed distribution, the skewness is greater than 0. So it's positive and it's skewed to the right. When it's negatively skewed distribution, it's skewed to the left, and then it is less than 0. When you say normally distributed, our skewness is equal to 0. Let's discuss a little more. Okay, here. When you say positively skewed or skewed to the right, it is the distribution where the thin end of the tail of the graph goes to the right part of the curve. So you can see here in our illustration that the mean is here in the right. No? Dool siya din sa ato right side. Na din ang center, ang arithmetic average na to dool sa left, sa right side. Kana. Ang mode na din dool sa left, atong middle is ang median. So mean, median, mode na siya dool sa right side. This happens when most of the scores of the students are below the mean. So meaning, kung makakuha gani ka og positively skewed nga data, gagmay ang score sa mga batas. They perform poorly. Kita na nila score asa dapit nag-cluster na dinhi dapit sa right side. I mean sa left side. Wala dinhi sa right, na sa left ang scores. You say it's skewed to the right, but the scores are in the left side, no? Tanawa gani ang drawing nimo, asa dapit ang pinakataas, ang peak. Di ba naa dinhi sa mode? Then dito man na sa left padulong, di man siya dito sa right, gagmay man ang score o gamay ra nakakuha og high scores dire. So it tells you only on poor performance of takers, but not the reasons why students did poorly in the exam. Okay. Maybe the reasons of performance are effective teaching method or instruction, students' unpreparedness, test items are difficult, or not enough time to answer the test questions. The second is the negatively skewed. If you say negatively skewed, the tail is on the left side, but the scores are on the right side. No? you look at the mean, median, and mode also sa left, but ang scores na din yung side, no? Kaya din na din ang peak sa mode, tanawagan aning blue, na din ang mga scores nag-cluster. So it is a distribution where the thin end of the tail of the graph goes to the left part of the curve. This happens when most of the scores of the students are above the mean, or mas taas sa mean. Okay, doon naman siya din sa imong right side. It tells you only good performance of takers, but not the reasons why students did well on the said examination. So, pag may tawag negatively skewed, dagko ang score sa mga students. Normal distribution is when it is a symmetric distribution and can be determined using the values of the mean and the standard deviation. So, katong nakita nyo ganyan nga normal curve, no? Nasa tunga-tunga gid ang koan. And kung tan-awon nimo siya later, ang mean, median, ug mode kay equal. Sa normal distribution, equal ang imong number sa mean, sa imong median, o sa imong mode. So if it's a normal distribution, the curve has a single peak, meaning unimodal. It is bell-shaped. It is symmetrical to the mean. The end tails of the curve can be extended independently both sides, and then the shape of the curve is dependent on the value of the mean and the standard deviation. So you can see here, this is a normal distribution. It's stated here that mostly the students are performing in the average, no, moderate, na sa tunga-tunga ilang score, no. So average performers ang mga students. Then naaring 10% nga mga non-performers, o naa kay 20% nga top performers, but most of the students are average performers, no? So ang scores na cluster dito sa middle, na ay gamay nga high, na ay gamay nga low, something like that. Sa muna ang normal distributed. So you can also see here the percentage. So if nga ni siya, ang imong mean equals sa imong median equals sa imong mode. We also have here the cortosis. We have the platycortic. When you have platycortic flat, no, kani, nak flat. Flattened ang peak, then heterogeneous, meaning vary ang score. When you say leptocortic, highly peak kani, taas iyang peak. And then homogeneous, meaning cluster ang score in a certain, in the middle. Kani siya, lagyo ang score ang kaning platy. Ang lepto is cluster ang score, kaabay-abay ra, kay homogeneous man. Ang mesocortic, ito atong normally distributed, normal distribution, it's normal, bell-shaped, and moderate in peak. Okay, so I hope it's clear. Platycortic flat, no? So, lagyo ang score. Ang leptocortic, dugol ang score, and then it's it's highly peaked. And then the last measure is the measure of relationship. This describes the degree of relationship or correlation between two variables. Like if you want to correlate academic achievement and motivation, so the relationship between the results of two administration of tests will determine the reliability of the instrument. The greater the degree of the relationship, the more reliable is the test. So Pearson error is the most appropriate measure of correlation. When the sets of data are interval or ratio type, it is most stable measure of correlation, and it's used when the relationship of two variables is linear one. If our relationship is positive, no, meaning they are of the same direction. If one goes higher, the other one goes higher. If one goes lower, the other one goes lower also. So if it's positive, if it's negative, then one goes up, the other goes down. Or if the other one goes down, the other one goes up. So they are opposite in direction. If it's negative, ang imong correlation nga nakuha. If it's zero, they don't have a correlation at all. I think that's all, and thank you. But let's answer this first before we end. Which is true when the standard deviation is big. Kung dako ang standard deviation sa ganito, meaning the scores are spread apart. No? Lagyo siya ang score. And then which group of scores is most varied? So kung may most varied, kano pinakadako og standard deviation? So asa na pinakadako? So 0.90 SD. Kana siya. Next. Study this group of tests which was administered to a class whom John belongs, then answer the question. In which subject did John perform poorly in relation to the group means performance? So atong gamiton din ang Z-score. Kay lahi-lahi man sila og mga subject, possible lahi po sila og teacher. So dili nimo ma-compare. It's not really comparable kay lahi ba ang teacher o lahi ang subject. So para ma-compare nimo siya, standardize nimo siya. Gamitan nimo siya sa standardized score or standard score, which is the z-test. So we know that z-test is the score minus the mean divided by the standard deviation. So for mathematics, you have 43 minus 56. So that's negative 13 divided by 13. That divided by the standard deviation, which is 10. So that's negative 1.3. Correct? So take note, our math is negative 1.3, our z-score. For physics, you have 31 minus 41, that is negative 10. Divided by 9, I think that's negative 1 point something. So that's negative 9, negative 1.1 something. So take note, for mathematics is negative 1.3. For physics is negative 1.1. And then for English, you have here the score is 109 minus 80 divided by 16. I think that's positive already, no? That's positive 1 something. So we will not we will exclude English because it's positive. Let's look at physics and mathematics because what we are looking is it's poor. Kung si gamay ang negative 1.3 or negative 1.1? It is negative 1.3 and it is mathematics. So the subject which John performed most poorly is mathematics. Next, Ruben scored 60 on a percentile rank test. This means that, kasi pasabot sa 60 nga score sa percentile rank ni Ruben. A, Ruben got 60% of the question wrong. Letter B, 60% of the students who took the test scored higher than Ruben, or 60% of the students who took the test scored lower than Ruben, or Ruben got to 60% of the questions right. The answer is letter C. 60% of the students who took the test scored lower than Ruben. Next, Tom's row score in Filipino class is 23, which is equal to the 70th percentile. What does this imply? A, 70% of Tom's classmates got a score lower than 23. B, Tom's score is higher than 23 of his classmates. C, 70% of Tom's classmates got a score of 23, above 23. D, Tom's score is higher than 23%, 23 of his classmates. The answer is letter A. 70% of the classmates of Tom got a score lower than 23. Kaya kung si Tom ang ika-70th percentile, so na 30 katao pa nga mas taas sa iya. Kung sa 100 siya, na below sa iya nga 70. So 70% of Tom's classmates got a score lower than 23. That's all and thank you.